Any question for me? All right. So if there's no question, let's see how a neuron looks like. When you watch the picture very well, when you watch the picture showing, that's how a neuron looks like. So there's the part where
Hello? I can't seem to hear anybody.
so this how a neuron looks like. A neuron is supposed to have the one part is called the dendrite. That's where it receives its information from. And when you get information, you pass it through the. You see the yellow spots here. There's yellow spots there. So these yellow spots where you process the information from. And when you process this information, it passes it through the axon. And the axon contains synapses. And these synapses, that's what they use to transfer the information to the terminals. And the terminal is the part that one signal is passed to other signal. And then one interesting thing about this neuron is that anytime an information enters this part here, they have to process it first. If the signal is not very high, it's not very high, they're not going to process it, or they're not going to transfer it to the axon to the terminals. They have to suppress it, unless the terminal is very like if it's reached a level or past the level. So there's the idea we also want to implement. This is the thing that you also want to implement. We want to also implement something like a neuron a node that has to receive a signal, process the signals, then pass the signal through this axon to the terminal. And this terminal can also transfer the signal to other neurons. So talking about the neurons, human beings is that each synapses. The synapse is like kind of a storage place or where they used to transmit the signals through. And that synapse storage size is around 4.7 bits. So you can just imagine the number of storage size the synapse having. Just one is 4.7 bits, and each neuron is having almost like 7,000 synapses. And when you come there, you can see that the human brain contains 86 billion neurons. Human brains contains 86 billion neurons. So if it's having almost 86 billion, you can just imagine the number of synapses in it. And one is like 4.7 bits. We are getting a lot of storage space in our brain. That's what some people use. That's what some people used to say that our brain is unlimited. Our brain is unlimited. So if you want to learn, you can learn very, very hard. Or you can learn a lot of information through your brain. So we're moving ahead. What I just said, the neurons do not use a simple linear function of the input and input. It doesn't just use a simple linear function of the input to produce an output. Like a neuron receive an input or a signal and they transfer that signal to another neuron. And so that process is not just something very simple or linear. What they do is that they suppress the input until it has grown so large that it has grown so large so that it triggers an output. It's like water in a cup, but water doesn't spill over until it has first filled the cup. So it's only sending a signal when it's sufficiently past the threshold. A function that takes an input and generates an output signal, but takes into an activation function. So, so this one thing you should just take note. You should just take note of this thing. It's very important. It said a neuron just don't pass any signals to the other neuron. He said their signal has to pass a threshold. So, so that's when they'll be, if they pass the threshold, that's when they'll be able to pass the signal to other neurons. And for our case, that threshold we want to pass is what we use something like an activation function. So activation function is kind of a function that we use to determine if a signal has passed a threshold or it has not passed a threshold. Because when you take your time and you listen to this neuron, I say a neuron only passes a signal to another neuron when that signal has passed a threshold. So it's more like a function that when the signal is able to pass over the function, it just fires. And that function for our case, we just call it an activation function. Mm. So you have to just take note of this one. Well, let's see how our activation function is going to work. We have a lot of activation functions. You can read about them. There are many activation functions like the step function, the turn age, and then one of the common ones is the ReLU. ReLU is known as the rectified linear unit. It's very common. If you should go ahead with your neural network project, you can see in a way you'll be moving to a bit of ReLU when you start doing a bit of more complex neural networks. But for our case, we just want a very simple one. It's one that its application and its difficult clause is very easy for us to understand. Because if you should understand this one, it's very easy for you to understand the rest one or the other part too. So we use our activation that we're going to use is called the sigmoid function. I'm going to use the sigmoid function. And that's the formula for the sigmoid function, yeah, the one you're seeing on the screen, the sigmoid function. So the sigmoid function is just like y is equal to 1 over 1 plus e exponent negative x. So that's the sigmoid function. And the x in it is just the x is just like a signal that will pass through it. Any signal you pass through it, it will just transform that signal. Just transfer the signal and give us an output. I don't know if you already know about it. The segment function is also known as the logistic function. And what you know about this logistic function is this. When you watch this diagram very, very well, you can see this signal takes input. You can see that this function can take the internet is not really helping us today. When you just watch this diagram, you can see that this signal, this function here takes input from negative infinity to positive infinity from the x-axis. But one thing you can just know about this function is that it only gives an output between 0 and 1. I don't know if you can notice it. The function you're seeing here, it only gives an output from 0 to 1. 0 to 1. Even though the x-axis can go from negative infinity to positive infinity. The y-axis always produces an output that is between 0 and 1. And that's one thing that we also need a lot. And that's one thing we need a lot. Because we also want to be able to, the activation I don't want to create, we don't want it to be able to just produce any value at all. It should produce values in a range, in a specific range. We produce value in a specific range that's between 0 and 1. Between 0 and 1. So that's something about this segment function. It's just a normal function that we know. And the other thing you're supposed to know is that anytime the value of our x increases, you can see that the shape of the segment function becomes flat on top. So if our x is around, like, let's say 10, 11, 12 to like high values, you can see that its output is always be like 1 when it's positive. And when the values are negative, like -8, -9, you can see that the value is always like the output of the segment function give you always be 0. It's always be 0. And this is what they refer to as saturation. If the values are very, very high and you pass it through the segment function, the outputs you're going to get are always become similar. If it's positive, you're going to get something like 1. And if it's negative, you're going to get something like 0. And that's what they refer to as saturation in the neural network. In the neural network. So, and it's one situation that we need to prevent. It's one situation that we need to prevent. We have to take note of also this one thing. So mostly one thing that we used to do to prevent this is just to try and analyze our inputs. So you range there when you keep on going for it. Alright, still talking about the neurons too. We also know that neurons can connect to other neurons. When you just watch this diagram, like the colors you're seeing, they are all connections. One neuron connects to another neuron. One neuron connects to another neuron. One neuron connects to another neuron. So we can have a lot of neurons connected together. And we also use this idea to also implement our neural networks. We should be able to get nodes or neurons that connect to each other. So for our case, this is how you're going to create our neuron. This is how you're going to, you just want to create something like a node. We call it a node. And then that node will see an input, then give an output. A node you see an input, then you give out an output. So for us, instead of calling it neuron, we just call this a node here. So this is what we refer to as a node in neural network. And a node can connect to another node, like what we just saw in the neural network, in the neurons. A neuron can connect to another neuron. The same thing here, you can also have to connect, a node can also connect to another node here. And nodes can also be in layers. You can see this one, you group them. You have grouped them here. And in this diagram, you can see that you have 2 layers here. You have 2 layers, 1, 2. And each layer is containing one node. Each layer is containing one node. Each layer is containing one node. So we have layer 1 containing this node. Layer 2 containing this node. So it's something that we should also keep it at the back of our mind. Keep it at the back of our mind. And this another see this diagram too. You can see this diagram, you are still having 2 layers here. One layer is here, another layer is also here. And inside this layer, each of them is having 2 layers. This one layer. Each of them is having 2 nodes. This one node and that node here in this first layer. And the second layer, you have the same thing. You have 2 nodes here. One is here, another is here. So these are some things that you should know. You should be able to differentiate between nodes. You also be able to differentiate between layers. Layers just group nodes together. Layers just group nodes together. So you should just know this in a lot. So when you just watch this out, so this how many layers do you think we have here? How many layers do we have here? Hello?
It will have to be layers.
You have three layers in. And you can see each layer is having
Two
two
nodes.
two nodes. Yeah, that's true. And and the other thing you also have to know is that each nodes are connected to each other using a link. And this link is what we refer to as our weight. And we call this link weight. So we call this our link weight. This node is connecting to this node using this link here. So this is a link weight. This one is connected to this one using this link here. So this is also a link weight. This one connected to this one using this weight here, link weight. Hmm. Nodes connect to each other using link weight. All right, so we can just move on. You can see, so this is how you call this link. This is how we used to name this link weight. You can see that we are written this on W11. And W11 just means that the first node in this layer is connected to the another first node in the next layer. And you see W12 is just like the first node in one layer here is connected to the second node in the other layer. And W22 is like a second node in one layer is connected to the second node in another layer. So W33 is the same thing as like a third node in one layer is connected to a second node in the another layer. So it is something you just have to know. It's just some terms and terminology you should just know of it. So if I should ask you like when you see a link weight of W12, can you explain the connection for me? The connection for W12.
I mean W with one two.
Yeah, W12.
It's going from node one to node one in layer one to node two in layer two.
Yeah, that's true. So long between layer two. So if you understand this one, I can just move ahead because there's some terms and some symbols that we should just know. So anytime when you see this one, this node here it always contains a value here. This node just it always contains value. Anytime you take a value here and just multiply by its link weight, and you take another one here, multiply by its link weight, you take another here, multiply by its link weight, and then just add it together. We call it a sum activation. We call it a sum activation. So you take this value, this node they always contain values. Anytime you take a value here, multiply by a link weight, take a value here, multiply by the link weight, take a value here, multiply by the link weight, just add everything together. We call it a sum activation. But then we just don't multiply in all these nodes by the link weight, just add it together. An example is this: if I just want to find the sum weight for this one, sum activation for this one, I just have to just look at all the nodes that are coming to this node here. When I watch the diagram, I can see this node is coming to this node is coming to this node here, and this node is also coming to this node here. So only these two nodes are coming to this node here. So to find my sum activation for this node, I have to take the value for this node here, multiply by its corresponding weight link here. Take the value for this node here, multiply by corresponding weight link here. Then I add those two values together. If I add those two values together, that's what we refer to as a sum activation. Refer to as a sum activation. A sum activation. So it's also another thing that we should also know too. So an example like this, you can see this node here. This node you are seeing here, you can see this one is almost like three nodes are connecting to it. This node here is connecting to it here. This one also connecting to it here. And this one also connecting to it here. So if I should just take this node and multiply by the corresponding weight thing, take this one, multiply by the corresponding weight thing, take this one, multiply by the corresponding weight thing, and add all of them together, I get something called it. Sound activation. Sound activation. So that's what they are explaining here. So for a given node, the inputs are multiplied by the weights in a node and summed together. So this value is referred to as the summed activation of the node. The summed activation of the node. The sum activation of the node. So now you have talked about activation function. You also talk about sum activation. They are two. They look very similar, but they are two different. They have two different meanings. They have two different meanings.
Just okay, there's sound activation and sound activation.
Is it
There's sound activation and sound activation.
sum like sum something, summed activation, like summing
Okay,
something,
okay,
sum and activation.
okay.
So this the meaning of what we just did. Like an example like this, imagine you have I just to said every node just contains input. Nodes they just contain input. So when you just take the input for like the node one here, A, and multiply by AWA, its weight link. That's what you're seeing, the A dot WA. Then this B by corresponding weight, WB. Then in this one by corresponding weight, WC. Then you sum everything together. That's what they refer to as our summed activation. And when you're able to sum all of them together, when you're able to sum all of them together, then we applied the activation function to it. And then we get an out. If we should apply the activation function to it, that will give us an output. So inside a node, or after a node receives signals, what it does is that it just adds all of them together by its what correspond their corresponding weights. When you add all of them together, then you apply the segment function or activation function to it. After applying the activation function to it, then the output they get from activation function will be the output from that node. Will be the output from that node. And this process is what we refer to as the feed forwarding. We just use this process to feed forward. But if one node passes its output to another node, we will do the same calculation on this again, then pass to another node. So we get to the final layer. So we get to the final layer. So now let's try and see what I'm just talking about. Let's just try and see if you can take an example of this. So let's see this one. You can see this one. You have node one. You have two layers here, and each layer is containing two nodes here. You can see input. The first node is put. The first node here, each input is just one. And the second node, the input, each input is just 0.5. So if I should take, can you see this node here? Can you see this node
Yes,
here? Can see this node is being connected by this link weight here, and another link weight to here. This link weight here, and another link to weight here. So to find my summed activation, guess what I can do? I just take one here and multiply by its corresponding weight. That's 0.9. Yeah. Plus I just take 0.5 here and multiply by its corresponding weight. That's 0.3. And all of them together. If I add all of them together, I'll do my summed activation here. Then when I'm done, then I apply the activation function to it. And that'll give me the output. So this is what you're doing here. So you can see that from this one, for the C, I took the 4, I took 2 and multiply by what 4. 2 is 2, I multiply by 4. Plus the 1.5, I multiply by 0.6. That gave me 1.7. So this is inside the input into this node is just 1.7. And I did something similar to for the D. And the input into that node is you can see when you just write it down, you can see it's just what one. Just one. So the input into this C is 1.7, and the input into the D is what? It's just one. So for
okay.
me to get the output, for me to get the output, For me to get the output for this one, just have to apply the so with 1.7, just have to apply the 1.7 to the activation function. And then this one, the 1 2, you have to apply it to the activation function. So that's what you're seeing here. So after you're able to apply it for everything in, if you can watch it well, after they're able to apply everything here, I see that down there they apply some function here, 1 over 1 plus h to the negative 1.05. 1.05. So when you're done finding the sum activation, you just have to apply the segment function to it. And that is going to give us from the node.
I can't seem to hear you.
You can't seem to hear me.
Okay, you're not loud enough.
I'm not really clear.
Okay, now you're clear.
Yeah?
Now you're clear. Before you weren't clear.
Yeah, I'm saying after you are able to find, I mean, you know how to find the sum activation, like how I was explaining to you, you
Yes,
understand how to look for
yes,
it.
yes.
So if you get a sum activation for each of the node, to get the output from the node, you have to apply the activation function to it. I have to apply
Is
this one, the 1 over 1 plus x with a negative x, like
okay.
what they are
Can you go
seeing
back?
for.
Can you go to the previous page? So you got 1.7 and 1. So how did you can go ahead? So how did you get 0.9 and 0.
Yeah, this calculation is a bit different from what you as was displayed there. You see,
Okay, okay,
yeah, it's a bit different from what was displayed there. I think this one is I was using a different values for it.
okay.
I think yeah, 0.5. What is 0.5? Yeah. Calculation for this one is a bit different from like the one it was displayed there.
Okay, so
If
just go back to the previous. So for the previous one now, do we add the 1.7 plus 1, then use the activation function?
yeah, the same thing. So just with this one, like this one, the what we got
Yeah,
1.7 here. Well,
yeah.
only the only thing I was supposed to just have to come to the down here. Just have 1 over 1 plus yes to the negative 1.7.
Okay.
Just have to just
Okay.
the x
Okay. So
over
you do for both of them, the
yeah, do
1.7
for,
and the 1.
and the one you have to do for both of them.
Okay. Okay.
Yeah. So when you do for both of them, that'll give you the output from that node. That'll give you the output from that node. So can you continue?
Yes.
Right. So what you just did, like you doing the sum activation and just applying activation function to it. That's what we refer to as our that's what we refer to in neural network as feed forwarding. Just passing the signal from one node to another node to get to the output layer. So in a feed forward network, information always moves in one direction. It never goes back. Connection of the nodes do not form a cycle. It doesn't form a cycle. It always goes from one node to another node. And let's give it output. It doesn't return again. It doesn't return again. Okay. So that's what they refer to as feed forwarding. Like it's not like you just be able to say they are doing a feed forwarding. They are doing their feed forwarding and stuff. That's the basic meaning of feed forwarding. Do you have any question up to this point? Do you have any
No, I'm
question?
good. I'm good.
So if you don't have any question, let me just try and with the feed forward, let me just try and just give an example so that you just work it out for me.
Okay.
I'll display it very soon. I'm just working it out. So try this one for me. Let me see. This one. Let's try and find the output. I just want the output from the node one and the output from the node two.
Mm.
The output from node one and output from node two. and leave it unsigned just two decimal places. Please, did you get me?
Yes, I do. So I got the output for node, what do you call it? Node one, layer two, and node two, layer two.
You said you node one had what?
I got 1.05.
That's for the is it the output?
Yeah, the output.
And when I talk about output, like you know what
No,
I
no, no,
mean?
no.
I mean,
Without the activation, the y equals to 1/1 e. I
okay,
haven't done that one. Just did the. Do you want me to do that one also?
yeah, I want you to give me the output for
Okay,
me.
can I get the formula for the activation? The one over one plus e.
That's a selection function.
Yes. Okay, I got for the first one I got 0.741.
That's 0.74. Okay, for all right, so that's true.
Second one I got 0.657.
Yeah, that's true. That's true. Wow. I mean, you understand what you're doing. Yeah, we understand what you're doing. All right. So this one part of the tutorial. The next one, the next section, we just have to see the same idea, but we just have to know how to convert this. We have to know how to convert this into a matrix notation form. The next one you have to see because you can't just be doing this thing manually. You should just have a way that you can just do it very, very fast. And matrix is very good with that. It's help you to just do this relation very, very quickly. So that's what we'll be looking at in our next session.
Okay.
Do you have any question?
No, no, I'm good.
Don't have any question. So now you just have to know the terms, like you know the fit wording, the sum activation, and even the activation function too.
So what are the peak words? Some activation, which is when you, which is the formula y equals to 1 over.
So that's activation function.
Okay, that's activation function.
Yeah.
Okay, some activation is the one where you use the weight and the corresponding weight times the corresponding number. Right?
Yeah, that's when you multiply the input by its corresponding weight, and then you
Mm-hmm.
add it. You add it to your other nodes that's connecting. It depends on the node you're working with. A
Okay.
node can have almost like two or three connections. So with each
Mm-hmm.
connection, you just have to multiply the input by its corresponding weight, then add it together. Add all the nodes together. That's connecting to the node, and that's going to give us our sum activation. And we're going to get a sum activation. You have to apply the sigmoid function to it. Are you an engineer mathematics student?
Yeah. I did the petroleum engineering at Tech.
At Tech.
Yeah.
Okay, I thought you're not Ghanaian. I thought you're not in Ghana campus.
I'm not in Ghana currently, but like I studied in Ghana.
You said it in Ghana. Okay, that's
Yeah,
nice.
finished graduated 2019. Yeah, graduated in 2019.
Alright, alright. So currently, like you're working in the petroleum engineering industry.
Yeah, but I'm trying to go into uh, the the tech sector right now. So I'm just trying to do data analysis as data science as my master's.
Okay, okay, that's nice.
Yeah, so I think I require like I'm trying to do data science slash artificial intelligence. So I think I need machine learning in that artificial intelligence part.
It's good. It's good. So yeah, I can see you are very keen with learning and stuff. So it's going to help you. It's going to help
You know, it seems like I'm putting a whole lot into my head because this morning I've been doing front end development throughout this morning, like from yesterday night to this morning. So
you. You're
now
learning.
this evening, huh? What do
You
you
said
say?
you're learning front end development.
Yeah, development because of Python and SQL and the rest.
Are you learning Python SQL at the same time?
Yes, like not at the same time, but I'm taking everything by shifts. So like this for like 2 weeks, I've been on. I did Excel and SQL for like 2 3 weeks. Then I did Power BI and Python. Well, I'm about to do that one like this week coming.
So it's
So
good.
like,
It's all
yeah,
good.
I'm just trying to take everything step by step.
Most people doesn't like anytime you're doing something else, a calculation comes inside. They don't like it.
No, me, I've always
Yeah,
been a math student now, so
yeah.
I think in tech, I've never had issues with maths. So even this one, so I know I was the one that had like I did the other class with you before, but I didn't follow up because I was always like I was not
So wait,
supposed
you
to.
did all this stuff. Before you done all this stuff.
No. Your last cohort, I was there, but I didn't. I only attended one class with you. I was the one who texted you on WhatsApp telling you that I wasn't able to attend all the classes. So you said that the new one you will let me know. I don't know if you remember.
Yeah, I remember. I remember.
Yeah, so like I think I had like the videos, like I downloaded the videos from last class, so I just basically went through it. So I went through the third and fourth class, first to fourth class this afternoon. So I just went through it and I understood all this before this class. Just some